Okay, so welcome. This is basically the algebra word problems, and I am going to basically give you a gift for those of you who are always ready for, in tune for this. So this is your test for tomorrow, and hopefully you're watching this. So the first problem says, Mr. Spellman expressed radical 450 in simplest radical form. He claims that the result would be 3. Oh, wait. Okay, let me see now. A little less. Okay, now we'll go see the whole thing, right? Good. Alright, so he claims that the result will be 3 radical 50. Is he correct? Can you connect the dots and explain his reasoning? Is there a more elaborate plan or more steps needed? Can the radical be simplified even more? Well, in order for you to actually do this, you need to first work the problem out, right? And once you've done it, then you could provide a written explanation with mathematical evidence. So you might need some loose paper, right? Scrap paper, whatever you want to call it. Let's see what's going on. So this is what Mr. Spellman says. That radical 450 is the same thing as 3 radical 50. Well, let's see what happens. This 3 radical 50 he must have gotten from somewhere. So when I am going to simplify a radical, I know that I have to find 2 factors of that radical, one of them having a perfect square root and the other one being irrational. Okay, so these 3 must have been the square root of something. So when I write it, I said, okay, I'm gonna write square root. This is basically what happened. It has to be radical 450 has to be the square root of something times the square root of 50. Well, that something is this number, but this number came from some radical. So what is the radical? It has to be 9 because the square root of 9 is 3. Makes sense? So that's how I connected the dots. All right, but the thing is that 50 can be simplified even more. Look, 50 can be turned into 25 and 2. Radical 25 times radical 2 is radical 50. Never forgetting that you had a 3. This is read as 3 times radical 50. Okay, so you bring down the 3, then times radical 50, which is radical 25 times radical 2. Then what is radical 25? Well, the square root of 25 is 5. So then you write the whole thing, you bring them down. 3 times 5 times radical 2, and you obtain 15 radical 2. So this proves that he is not completely incorrect, nor is he completely correct. He needed to simplify radical 50. He forgot about it. All right. Now, no, that's it. So now we're ready to write our written response. Okay. So let's see now. So this is the written response. Mr. Spellman is not completely correct, nor is he incorrect. He simplified radical 450 into radical 9 times radical 50, yielding in 3 radical 50. But he forgot to simplify the radical 50, which radical 50 is radical 25 times radical 2, which is radical 5 times 2. Okay, now the whole expression becomes, and remember that we had to bring down the 3, right? This 3, because this is 3 times radical 50, so this is 3 times whatever we got from radical 25, okay, times radical 2. So now we got 3 times 5 times radical 2, which is radical 15. I'm sorry, 15 times radical 2. So this is the simplest form. Now you have to think outside the box. Is there another way? Well, a different approach would be, or would have been, to simplify radical 450 into radical 225 times radical 2, because this is also radical 450. And remember, it's always a good thing to find the largest perfect square. So 225 is the largest perfect square. So now the square root of 225 is 15 times radical 2. So 15 radical 2, same simplest form answer, simpler approach. Got it? All right then. So now let's move on to the next problem. Okay, now we can move on to the next problem. So again, Mr. Spellman, I need to maybe change the name again. All right. So he's saying that the expression radical 150 plus radical 8 in simplest form, okay, he claims that the result will be radical 7 times radical 2. Is he correct? Can you connect the dots? Explain his reasoning. Is there a more elaborate plan or more steps needed? Can the radicals be simplified even more? Well, you know what? There's only one way to do this. We write what he was given. Radical 150 plus radical 8. Okay? Nice, a beautiful 8. Okay. So radical 150. Radical 150 is 25 times 6. That's the largest perfect square. And we know that this is 5 times radical 6. Okay? That was this part, radical 150. Plus, now radical 8. Radical 8 is radical 4 times radical 2. That's radical 8. So this is 2 times radical 2. Okay? So now, is there anything else? Let me see. No, let me see. 2. Nope, that's it. I mean, you cannot simplify radical 6 anymore because you don't have two factors of 6 that one has a perfect square. I mean, that one is a perfect square. And radical 2 cannot be simplified anymore. So then this is your final answer. Okay, we know that the homie is incorrect. But the problem that I find with this is that he is saying that the answer, okay, sorry, like that. He is saying that the answer is radical 7 times radical 2. Where is he getting this information from? Well, radical 7 times radical 2 is radical 14. Right? So, is he correct? Can you connect the dots? Explain his reasoning. I cannot explain his reasoning. How can this be? What can he be thinking about? I get that he might have added these two numbers, but I don't get the fact that this is a 6 and this is a 2, and you cannot combine them. So radical 7, yeah, this is the only thing that makes sense from Mr. Spellman. Then this doesn't make any sense how he combined them. You cannot add them like that. And not only that, he's so confused that instead of addition, he used the multiplication sign. So that's fine. Now that we know what the answer is, then we go and we write our explanation. Okay? So Mr. Spellman is incorrect, and his reasoning is faulty. You like that word, right? Faulty. Okay. Because he went from adding radicals to multiplying radicals. If you cannot read this, at least you're listening to what I'm saying, so that's it. Okay. Multiply radicals. So radical 150 plus radical 8, okay, can be simplified as, or can be simplified to 5 radical 6 plus 2 radical 2. Okay? And then you could put the following here if you want to, because there are different ways of doing this. Mathematical evidence. Okay? So radical 150 is equal to radical 25 times radical 6, and radical 8 is equal to radical 4 times radical 2, right? Therefore the result is, and look, radical 25, so we got 5 radical 6 plus 2 square root of 4 radical 2. And they're not like terms, so you cannot combine them, as simple as that. Okay, next one. Let me see now. Alright, your job pays you 6 radical 50 plus 6 radical 2 per hour. So this is how much you make per hour. Right? Alright. Now, if you work a total of radical 288 hours in one day, how much money do you get paid in simplest radical form? Well, look at it this way. If you make $10 an hour and you work 8 hours, how much you getting paid? $80, right? Because you multiplied. Well, the same thing is gonna happen here. Whatever you obtain from here, you're gonna multiply by 288. All right. How much money do you get in simplest radical form? Okay, so then let's start simplifying this. 6 times radical 50 is equal to 6 times radical 25 times radical 2. 25 times 2 is radical 50. Okay? And, okay, 6 radical 2 is already in simplest form. So I just have to add them. Okay. Therefore, we have 6 times radical 25 is 5 times radical 2, which is radical 2, plus, and now 6 radical 2 is just 6 radical 2. Okay, which is equal to 6 times 5 is 30, right? 30 radical 2 plus 6 radical 2, which is equal to 30 radicals 30 of this plus 6 of this is 36 radical 2. Okay? Cool then. Now, next, we have radical 288. Okay, we have radical 288, which is right here, which equals radical 144 times radical 2. 144 times 2 is 288. So radical 144 times radical 2 is radical 288. Okay, which is equal to the square root of 144 is 12 radical 2. Okay, so you get paid 36 radical 2 and you work for 12 radical 2. So how much money do you get paid? Well, I get paid, so I get paid 36 radical 2 times 12 radical 2. So how do you multiply this? Easy. You multiply the natural part and then you multiply the radical part. So, question is, what is 36 times 12? Well, you're gonna have to use your calculators. So we get 432. And what is radical 2 times radical 2? That's radical 4. And what do I know? That radical 4 is the same thing as 2, because square root of 4 is 2. So then, what do we get? Well, that's up to you. I'm not gonna tell you, but I'm gonna move on to the next problem. Okay, so here we got polynomials. Pum, pa-dum, pa-pum, pa-pum, pa-pum. Find the sum of difference by combining parts that are alike. Okay. What strategy or property did you use? Explain. So, you're given this polynomial right here, or this algebraic expression, and you're supposed to simplify it by combining like terms, or using the distributive property, or using the commutative property. So let's see. Sorry, just follow this. This is the way I need you to answer this problem. So it says this is a polynomial expression, and I need to simplify it by using the distributive property. You have to write that. Well, you might not need to use the distributive property, but in this case we are. So I'm gonna use the distributive property on negative 12 times m minus 3. So negative 12 times m is negative 12m. And negative 12 times negative 3 is positive 36. So we need to remove the parentheses. There is no negative. If there was a negative here, you will have to multiply the negative and distribute the negative. But since there is not, then you don't have to do anything. There is none. So you remove the parentheses and we get 4m plus 6. Here we use the distributive property, so we have negative 12 times m is negative 12m. Negative 12 times negative 3 is positive 36. This is a positive sign, so we just leave this the way it is, m plus 2. If this had been a negative sign, we would have to distribute the negative, okay? But it's not. So now here, it says I remove the parentheses after applying the distributive property, and now I'll combine like terms. Now when I say I'll combine like terms, I can also say now I will use the commutative property to group like terms together. So you see, that's another way. I'll use the commutative property to group like terms together. So then when I use the commutative property, what do I get? Look, 4m minus 12m plus m, they together. 6 plus 3 plus 2, natural numbers together. So then what do I get at the end? Well, 4 minus 12 is negative 8. Negative 8 plus 1, m, is negative 7. See that? You could use the calculator if you want to. And then 6 plus 3 is 9, plus 2, 11. Boom, That's what you got. So you have to basically provide a written explanation. It might not have to be like the one I provided here, but it has to be very close, very, very close, explaining the properties that you're going to use. Okay? Because I took the time to write this, now you have to take the time to write it. So I will say what I need to do. I'm only going to do one of the problems. Let me see, maybe I should do number 4. Yeah, I think number 4 is good. So look, this is a polynomial expression and I need to simplify it. I will use the distributive property first. And I will also remove the parentheses. So here, there is no negative, so I don't need to distribute that, so I just remove the parentheses. Here, there's a 6 multiplying that, so I have to use the distributive property. So 6 times t squared is 6t squared. 6 times negative 8 is negative 48. Okay. Now look, there's a negative, there is no number, and there is just the parentheses. So I need to distribute multiply the negative. In other words, distribute the negative to the inside of this little expression of the parentheses. So negative times t squared is negative t squared. If you want to, you could put a 1 here, really doesn't matter. So negative 1 times t squared is still negative t squared, or negative 1t squared, really doesn't matter. Negative times positive 12 is going to be negative 12. Then you write. Now I will group like terms together using the commutative property. So we get negative t squared plus 6t squared minus t squared. Now 5, positive 5, right? Minus 48 minus 12. Okay? Boom, boom, bing, bing. Okay then. So now let's see. Now let's add the like terms. Okay, negative t plus 6t is negative 5t. Negative 5t squared minus 1t squared is negative 4. Sorry. Not negative 4. Negative 1 plus 6 is 5. 5 minus 1 is 4, sorry. So this is 4t squared. And now the natural parts, natural numbers, the integers. 5 minus 48 is what's 5 minus 48? Oh, negative 43. Negative 43. Wait, hold on a second. I'm not gonna do this part. You could do it yourselves, because then I'll be doing the whole thing. So do that, and that will be your resulting expression. So you do that, and the same way you gotta do this one. Okay? And for this one, okay, fine. Do you remember how to use the distributive property? Whenever you have two binomials. Well, let's see. You remember this? And then look. When you multiply a regular number with a radical, it's just a regular number with a radical. Just like when you multiply 3 times x, you get 3x. What is radical 2 times 4? Radical 2 times radical 2 is radical 4. That's as far as I'm going to take you. Now you have to figure out what you're gonna do. If there are like terms, if there are things that you need to simplify, you do it. If at the end you have to add some numbers, you figure it out. So this is as much as I'm gonna do for you. I hope you know how to appreciate this. And remember, it's always beker time. And so if you get the alerts, you'll be Gucci. I'm gonna upload this now.